Welcome to Manifested Publishers.
Hello learners, welcome to this lesson. It is Chemistry Form 2 and the topic is Chemical Families and Patterns in Properties. If you remember in the previous lesson, we discussed the chemical families and we discussed a brief about the alkali metals. We said they are also called group 1 elements, and we also wrote the electron arrangement of the first three group 1 elements. Lithium was the first element. We said the configuration is 2, 1 because it has 3 electrons. The second was sodium. The configuration was 2, 8, 1. And the third was potassium. And the configuration was 2, 8, 8, 1. Since that the reason why they are called group 1 elements is because they are having one electron in the outermost energy level. And the one electron enables them to be placed in group 1. If you look at those three elements, that the sizes are different, that lithium is the smallest and potassium is the largest, depending on the number of energy levels which are present. That lithium has 2 energy levels occupied by electrons, sodium has 3 energy levels occupied by electrons, and potassium is the largest with 4 energy levels which are occupied by the electrons. And therefore, that's why we are saying that the size of potassium is larger than the size of sodium, and the size of sodium is larger than the size of lithium, depending on the number of energy levels which are occupied by electrons in each atom or in each element. In this lesson, I want us to discuss the gradation in size of atom and ion. Gradation in size of atom and ion. Remember, this is gradation in size of atom and ion of alkali metals. So gradation just means there's a systematic progression. A systematic progression on the size of atom and ions in group 1 elements. And I will explain this using a table which I'm going to draw for you so that we discuss it from there. This table is having the element. Therefore, that is the table. I want us to look at the gradation in size of the atom and the ion of alkali metals. These are the alkali metals. So the alkali metals are lithium, sodium, and potassium. Then their symbols, the letters are not supposed to be touching one another. So we have lithium, sodium, and potassium. Those are the symbols. The atomic number, lithium has atomic number 3, sodium has atomic number 11, and potassium has atomic number 19. Then writing the electron arrangement, these ones we have already written or discussed that in the previous lesson. So lithium has configuration of 2,1, sodium 2,8,1, then potassium 2,8,8,1. Then we look at the atomic radius, that the sizes of the atom and the ion, these ones are too small, and hence you cannot be able to measure them in the laboratory because their sizes are too small. You can see the units of measurements, they are nanometers. Nanometers are very small units. You cannot be able to measure them. It's too difficult because their sizes are too small. The sizes of the atoms of these metals or these elements are too small. So you cannot be able to measure them unless under special places. So the atomic radius are measured in nanometers. If you look at the atomic radius lithium atomic radius 0.133. That is the atomic radius of lithium. Then sodium, the atomic radius is 0.157. Potassium, the atomic radius is 0.203. The ionic radius for lithium is 0.060. Then for sodium, the atomic radius is 0.095. And for potassium, the atomic radius, not atomic, but ionic radius is 0.133. If you look at the atomic size and the ionic radius sizes, then both are increasing down the group. So we can say that atomic radius, we need first of all to define what atomic radius is. This is the distance from So atomic radius refers to the distance from the center of the nucleus of an atom to the outermost energy level occupied by the electron or electrons. For example, if this is an atom, this is an atom, this is the energy level. This is the nucleus of that atom. Let's say atom is lithium. So the lithium atom, this is the first energy level. The first energy level has 2 electrons, and the outermost energy level has 1 electron because the configuration of lithium is 2-1. So 2 electrons in the first energy level and 1 electron in the outermost energy level. Therefore, the atomic radius is now the distance from the center of this nucleus to the outermost energy level. So the distance from here to here, that is what we are calling the atomic radius. So refers to the distance from the center of the nucleus of an atom to the outermost energy level occupied by an electron or electrons. So this is an atom of lithium. An atom of lithium looks like that. Then when you talk about the ionic radius, we are referring to the radius of these elements having undergone ionization or having formed ions. And these elements, they form ions by losing 1 electron in the outermost energy level. Group 1 elements So group 1 elements form ions by losing 1 electron in the outermost energy level. Therefore, if they lose electrons, or they form ions by losing electrons in the outermost energy level, they become ions. And when they become ions, then the number of the energy levels are going to reduce. So they are going to be like this. So lithium is an atom. When lithium loses 1 electron in the outermost energy level, then it will be positively charged. And the reason why it is positively charged is because it now has more protons than electrons. It has more protons than electrons. Remember, the atomic number is 3. The atomic number being 3, it means that it has 3 protons and 3 electrons. 3 electrons in the atom. When it forms ions, it has lost the 1 electron in the outermost energy level. So there are more protons than electrons. So the difference is just 1, and that's why it becomes positively charged, because you see that protons are positively charged. Protons being positively charged and electrons are negatively charged. Therefore, the net charge when lithium or any alkali metal loses 1 electron, then they become positively charged. Therefore, the configuration or the electron arrangement of this lithium ion will be 2. Then we have sodium. That sodium, when sodium loses 1 electron, it will also become a sodium ion, just having a charge of a positive, because after losing 1 electron, it has 10 electrons remaining and 11 protons in the nucleus, and therefore the net charge is a positive. Therefore, the configuration will be 2, 8, because it has lost 1 electron in the outermost energy level. For potassium, again it will be potassium ion, and once it loses 1, the configuration will be 2, 8, 2, 8, 8. So those are the electron configuration of ions or group 1 elements when they lose or when they form ions. And they form ions by losing 1 electron in the outermost or from the outermost energy level. So you can see that these were the electron configurations of the ions. These are the electron configurations of atoms. These are the electron configuration of ions. And therefore, you can see that if you look at the atomic radius, or if you compare the atomic and ionic radius, then you can see there is a decrease in the size. But first of all, let us start with the atomic radius. How does the atomic radius of alkali metals compare? How does the atomic radius of alkali metals compare? So the atomic radius of alkali metals increase down the group. The atomic radius of alkali metals increase down the group. This is because there is an extra This is because down the group, there is an extra energy level occupied by the electrons. If you look at the atomic radius, this is 0.0133, 0.157, 0.203. So there's an increase down the group. And we have explained this by saying that the reason why the atomic radius is increasing down the group, it is because down the group there is an additional or there is an extra energy level which is occupied by the electrons. If you look at lithium, this has 2 energy levels occupied by electrons. Look at sodium, has 3 energy levels occupied by electrons. And if you look at potassium, it has 4 energy levels occupied by the electrons. And therefore, you can see as you go down the group, and going down the group means from up going downwards. So there's an extra energy level occupied by the electrons. So the number of energy levels increase as you go down the group. The next is ionic radius. ionic radius increase down the group. This is because so again, ionic radius increase down the group, and this is also because down the group there is an additional energy level occupied by the electrons. And this one can be explained using what I have written here, that lithium, after forming ions, has been left with one energy level. Sodium, after losing one electron, has been left with two energy levels. Potassium, again, has been left with three energy levels. And initially, lithium had 2, sodium 3, potassium 4. So again, as much as all of them have lost, that all the three elements, each element has lost one electron from the outermost energy level. So still, the ionic radius down the group still increases, because down the group there is increase in an additional, or there's an additional energy level which is occupied by the electrons. And that's why the ionic radius also increases, just like the atomic radius down the group. And the other thing I want us to discuss is comparison between the atomic radius and ionic radius. Comparison between atomic radius and ionic radius. So if you look at the atomic radius and ionic radius, for lithium, the atomic radius is 0.133. The atomic radius of the same lithium is 0.060. So you can see the atomic radius is larger than ionic radius. For sodium, again, atomic radius is 0.157. Then for ionic radius, the ionic radius is 0.095. Again, the atomic radius is larger than the ionic radius. For potassium, the atomic radius is 0.203 and the ionic radius is 0.133, showing you that in alkali metals, all group 1 elements, that the atomic radius is always larger than the ionic radius. And the reason is that atomic or group 1 elements form ions by losing one electron from the outermost energy level. Therefore, group 1 elements which we are calling alkali metals form ions by losing one electron from the outermost energy level. They form ions by losing one electron from the outermost energy level. Therefore, once that one electron has been lost, the remaining electrons are pulled much closer to the nucleus. Therefore, So the remaining electrons are pulled much closer to the nucleus due to the higher nuclear charge. What I mean is that once this, okay, the atomic number is 3 for lithium is 3. It forms ions by losing 1 electron. Once it loses that 1 electron, 2 electrons are remaining. 2 electrons are now remaining in only 1 energy level. How many electrons are there in the nucleus? There are 3. So if this is a lithium atom, that here we have three protons which are positively charged in that nucleus. So these 3 protons which are positively charged, they are now pulling the 3 electrons in the energy levels. So if 1 electron is lost during ion formation, then 2 electrons are remaining. Therefore, it means that the force 3 protons is pulling 2 electrons is higher than the force it would use to pull the 3 electrons. So there is more force, or the 2 electrons are pulled much closer, or they are pulled more than the 3 electrons. And that's why we are saying that group 1 elements, that they form ions by losing 1 electron from the outermost energy level, and therefore the remaining electrons after ion formation, they are pulled much closer due to the higher nuclear charge at the nucleus. So this higher nuclear charge, and that's why the ionic radius for group 1 elements will always be higher. The ionic radius will always be lower than the atomic radius. Therefore, that is what I wanted you to understand in this. That when you are comparing, then use comparison terms, that the atomic radius is larger than ionic radius, then explain this way, that group 1 elements form ions by losing 1 electron from the outermost energy level, and therefore the remaining electrons are pulled much closer to the nucleus. We would have started by saying that the atomic radius is larger than ionic radius. Therefore, the atomic radius is always larger than the ionic radius, because group 1 elements form ions by losing 1 electron from the outermost energy level, and therefore the remaining electrons, they are pulled much closer due to the higher nuclear charge at the nucleus. Therefore, that brings us to the end of our lesson today. But before that, I need to give you the assignment, and the assignment is that's assignment 1, define an atomic radius. So you should be able to define, because we have done that. And second, compare the atomic and ionic radius of alkali metals. You should be able to do that. So ensure that you've done that before you meet in the next lesson. In the next lesson, we'll be discussing the physical properties of alkali metals. Thank you for participating in the lesson. See you in the next lesson. Bye.